video goes over Chapter 15, Non-Renewable Energy Sources, the Impacts and Energy Conservation from the Essential Environments textbook. And it starts out talking about the process of fracking. And fracking is something that, people are really starting to hear about and have been hearing about, for maybe a decade now. There's this really great TED Ed that talks about how fracking works. And it's called How Does Fracking Work by TED Ed. But basically, it's natural gas that from dead and decaying organisms, they've decomposed under the ground and they've created this gas. And in with the process of fracking, basically, a hole is bored down into the ground first, vertically and then horizontally, and then it basically cracks open this layer of shale. There's like a water chemical mixture that's inserted, and basically gas. This is all cracked during the process, and a natural gas is released and collected. So this process has been something that's been really taking off in the United States. Different policymakers have like passed exemptions so they don't have to comply with like the Environmental Policy Act or the Safe Drinking Water Act. Interesting. Gas companies don't have to disclose what chemicals they are using here as part of fracking. So this has really gotten kind of a fast pass or free pass as a way to extract natural gas, and with some people they feel like it shouldn't have received that free pass, and some people think it should. So it's a hotly debated topic. So these are different sources of energy that, and these are not all inclusive, that we could use, and are commonly seen here in the United States. And if the energy source is non-renewable, like coal or oil or natural gas, or if it is renewable, like hydropower, solar energy, or wind energy. So the non-renewable means that we would generally expect in our lifetime that we are not going to see it again at any time soon, or like it's not going to replace itself in any, like within our lifetimes. However, renewable will, like sunlight is going to keep coming down every day. So these fossil fuels, the place that they came from is when dead and decaying organisms, which we always think of just dinosaur, although lots of it is just ocean material or plant material. However, when these organisms have died, they are compressed over time and produce an oil. It can be gas, it can be coal. So our consumption on these has gone up and up and up over time. We are just using more and more of these energy sources over time and are using more than ever, which is not a big shocker because our reliance on electricity and other power sources just goes up all the time. We're just using more and more. So this is the world energy production and generation by different sources. And you can see some of the top sources are oil, coal, natural gas. A lot of like hydropower and nuclear are also used throughout the world. And this is the reserves of different countries, how much oil reserves they have. And the top countries are Venezuela, Saudi Arabia, Canada. For natural gas, Russia, Iran, and Qatar. And for coal, the United States, Russia, and Australia have some of the top reserves for these different fossil fuels. So developing countries tend to use their energy more to build their country, to develop up their country. Whereas in the developed world, we use it more for industry or transportation and things like that. So harvesting energy takes energy. So to get, energy out, there's something called the estimated return on investment, EROI, which is basically like, if you can only put out $100 worth of machine equipment and manpower, but get $1,000 worth of product from that, then that's a high return on investment. However, we've seen over time that as these fossil fuels are reduced, the return on the investment is less. Like, for instance, because it's harder to reach different reserves under the ground because, the easy ones are all taken already. So, as it's harder to get to those reserves, maybe you have to put out $500 worth of manpower and machinery, and you only get $700 worth of product. So, the return on investment is less over time. So that is all calculated to find out if it's worthwhile to go in and get a certain reserve. So generally, oil and gas wells are having to be dug deeper to get at oil that we weren't able to get to before. Also, they're going up into the Arctics or off the oceans a lot more because the easy ones on land are taken. So, fossil fuels were formed long ago, and we already talked about that. And different types are coal. Coal is a hard substance from like woody things, like solid carbon structure. And to get to coal is very dense. You can have a strip mine where an area or like mountainside is kind of like one area is extracted off. You can have subsurface mining where tunnels and caves are dug and people or machinery goes down into those tunnels, or you can have full mountaintops removed and that really, or blown away to get at the reserves down below. There's also crude oil, which it's called crude because it's unrefined from the ground. You can have natural gas, which is a form of methane, and that can be brought up in a gaseous form. And then you can have petroleum. Petroleum is a mixture of oil and natural gas together. To find out where these reserves are, they'll do something called exploratory drilling, where they will drill different holes down to and place different sensors, meters down there to find out what is there. So, there's a few other types that we could go into, but I want to look at this. The economics of how much is extracted versus used per country. So, here with oil production, the United States uses or produces about 17.9% of the world production comes from the United States, but the consumption of oil is 19.7. So this is where the United States is relying on other countries for their oil. Whereas natural gas, the United States is producing 23.1% of the world production, but we are only consuming 21.5% of the world production, which means we are selling some of it or making money off of that. And you can see other countries and how they flesh out. So oil is refined. It's not all the it's not all valued equally. It's refined and it's used different levels of the oil is used in different ways. Some of it per barrel will be used as gasoline. Some will be for like heating oil, jet fuel. All these different purposes are like different parts of the oil used for. Specifically, electricity is made, and this same pattern is used in a lot of places, even like nuclear when we talk about it. This is the general pattern for most things. So in this case, coal is used to burn and light basically either steam from a broiler or just heat. Heat will come up and boil something like water. That boiling water will spin a turbine and you can generate electricity off of that in a number of different ways. And it is otherwise, that's how you generally get electricity from most of these, is by heating water, which spins a turbine and generates power that's converted to a form that you can use. Inside of our homes, we have a lot of fossil fuels. Nearly everything that we're using is from fossil fuels, like these synthetic sources. Really, a lot of different components of what is brought up is used in the end. Hardly any of it is wasted, and they're made into all kinds of different products that you can see here. So fossil fuels, are non-renewable. Um, so in 1956, there was a geologist that said the United States would hit our peak oil production in 1970. This prediction was true in a way, except that we started moving to non-conventional sources of oil, and we have continued to go towards a peak that we haven't quite reached yet as far as what we are using. However, there's a lot of countries, including the United States, who are thought to be nearing their peak, and you can see the United States we're here at the bottom, nearing the peak of our reliance on oil as we move to other methods of getting energy. So there's been a lot of impacts on getting fossil fuels and having to deal with the environmental impacts. Like I said before, the mountaintop mining, basically fracturing, offshore welling, all of these have different impacts on the environment. Mountaintop removal, this is an aerial photo of mountaintops that have had their tops fully removed to get to the different coal seams that were below. Out in the Gulf region, they have done a lot of oil drilling, but then of course that comes sometimes with spills that not only can disrupt tourism when that happens, but it can wreck ecosystems and kill different species. We can store and capture carbon in different ways, and this means pulling it from the ground, and then also we can capture that and use it for different purposes. So when there are different emissions from these things, there are external costs to using these and to extracting them that all people in general pay. We all pay various medical expenses for having dirtier air or for environmental cleanup, having these things leach into our water. It's kind of a societal cost that we all pay for these that aren't necessarily paid for when you pump the gas or by the companies who extracted it. So we can also have long-term damage from climate change. So those are all considerations in taking in when we are doing that. And basically, those have to be weighed out with like the people if they are going to continue like buying it and supporting the industry or not. So Americans in general, this is our line here, use a lot of energy. There's a couple countries on this chart, Saudi Arabia, I'm guessing for air conditioning purposes, and Canada, I know for heating purposes, that use a lot more energy per person than we do. However, if you looked at a lot of other countries in the world, per person, they're using a lot less energy than we are. So one of the things that has been pushed for a while is to get Energy Star appliances or appliances that don't use as much energy, so they work just as well, but you don't have to pay as much out electricity wise and or gas wise or whatever power source it is. So you get to save that money for yourself. So that's been pushed. There's a few videos that I would highly recommend watching on nuclear energy. They are all four of them are Kyrgyzstats, and they are on the names of them are nuclear energy explained. How does it work? And then the next one is nuclear energy is terrible, nuclear energy is awesome. These are a 3-part series. And then separately, this last one is called Do We Need Nuclear Energy to Stop Climate Change? And so basically this video series, as well as your book, is talking about how nuclear energy has gotten a really bad rap, but has gotten a lot more efficient and can produce a lot of power with very little impact on the environment. So it's something that doesn't necessarily match the narrative that you have heard. So I would recommend just consider watching that so that you get a more balanced view of nuclear power. So the United States has a lot of nuclear power generation plants, although France actually depends on it a lot more. We have shut down a lot of our nuclear production and it has slowed in the United States. Specifically, the way that nuclear energy works is that one atom will be broken into smaller atoms, and that releases a lot of energy. That's called nuclear energy. The process happens inside of nuclear reactors, and nuclear fission is the splitting of these atoms. So there's always a moderator in here, which is usually water or graphite, and it slows this fission process down so that it can cause a chain reaction that makes more power. And there are different control rods inside of the reactor. This looks very similar to the last diagram that we saw on how power is made with coal, but a very similar process. Basically, the nuclear fission happens here in the reactor core. That reaction of breaking the atom up releases a lot of energy. It heats up a water source, which in general can turn a turbine, which generates power and made into a form that you can use. So it does make some subatomic particles, and that radioactive isotopes have to be dealt with over time. However, they now do have safe ways of dealing with that. So, Sweden is one country that has cut its fossil fuel consumption down quite a bit and is starting to use nuclear powers. In the United States since the 1980s. Our growth has really slowed because the public outcry against it, and it's been very stigmatized as being a negative thing. And that basically, if you go look up those videos by Kyrgyzstats, it will finish out nuclear and you'll have a much better view or idea of what that looks like.